So, this is Mr. Springer. Hopefully, everything went well with my surgery, and this is Tuesday, and you have, or maybe Wednesday, and you have been working on multiple choice questions from the packet, starting on page 33. Yes, 33. So, here we go. I didn't want to just put them all in there because of who knows why. Anyway. Number one, it's wanting to know which of the following correctly ranked substances listed above in order of increasing ionic character in their bonding. So you got to remember that, well, I like to think of it this way. Make sure my pen's turned on. It is. That it's kind of a continuum where the electronegativity difference, if that's 0, that is nonpolar. As the difference gets larger, like very large would be ionic, and then somewhere in the middle is just polar covalent. So we're looking for increasing ionic character. So nonpolar, it's usually the same element. Polar will be different elements but fairly close together. And ionic, for the very ionic, they are going to be very far apart. So we want to have atoms that are, or elements that are closer together on the, as the least ionic, and then the farther apart as more ionic. So the S and the Cl, they're right next to each other on the periodic table. So this will be the least ionic. And barium is way down there on the bottom left corner. It's in the second column, but it's still pretty far from chlorine. So this will be the most ionic. So the correct order is SCl2 is less ionic than CdCl2, which is less ionic than BaCl2, which means that the correct answer, I believe, is choice B, if I'm not mistaken. Okay, similar on number 2. Close together is less polar, farther apart is more polar. We're comparing, oh, they're all different on this one. So on letter A, the ClCl, that would be the least polar. And since we're going on increasing polarity, A is not it because it's going at the very minimum. The last one is the least polar, and we want the last one to be the most polar, so it can't be A. Let's see, what does it look like on B? Well, it's got the SS first, which would be least polar. But if you look at the other two, ALS and P and S are right next to each other, so that would be less polar than ALS, which is farther apart. So that's no good. Right, did you get that? P and S are pretty close together. So that would not be the most polar. That would be somewhere in the middle. Letter C, we got SiO, SiC, and SiF. SiF are far apart. That would be most polar. But Si and C are very close together, so that's no good. Right, we would want that one to be, we'd want SiC to be the first one in the series rather than the middle one. So that only leaves SeBr on letter D, SeBr, SeCl, and SeF, I believe. And you'll notice that is the column 7A on the periodic table, that's the halogens, and bromine is below chlorine, which is below fluorine, which means that those are getting the fluorine, right? That we're looking at electronegativity difference. Bromine is not as electronegative as fluorine, so the biggest difference will be the one with fluorine, and so that's the largest. This will be the least. D is the correct order. Lattice energy on number 3. We want small radius. We want larger charge. And looking at the 4 choices there, it looks to me like well, I'm going to throw out A and B immediately because their charges are small. So let's say it's not A nor B, right, because they both have a 1 for the charge. So then let's look at C and D. Both have charges of +2 and -2. They're both comparing to O, which is very small. And of the MG and CA, MG is smaller than CA. So the smallest radius, MG and O, and the largest charge, +2, -2, it looks to me like the answer is C. MG 2 plus, O 2 minus would be the best bet there. If it were going to be either A or B, I would go with A, but I believe C is the correct answer. Next, we're looking at some of those graphs. We looked at some of those earlier. Remember, the x-axis is distance between the molecules, so that is getting larger as we go across. And how deep it is how strong the attraction is, or it's the amount of energy to break the bond, or the energy given off when the bond was made. So we've got CF and CCl, F being smaller than Cl. So the CF bond should be shorter, which means that the CF curve should be to the left. And we can see that the CF curve is on the left on A and B. So it can't be C or D. And then we want the one where the CF bond, which is shorter, is also stronger, meaning deeper. So we want CF to be deeper than CCl. The correct answer is A. Next, we've got a CC single bond versus a CC double bond. Remember, double bonds are shorter and stronger. So the CC double bond should be deep and left. Deep and left for the CC double bond. I'm looking at B as my answer there. Okay. Next, we're going to predict the lattice energy. That's all been the same theme here. We've got NaCl at 788. We want to know if NaBr is greater than or less than 788. Well, bromine is a larger atom. The bromide ion would be larger than the chloride ion. So the lattice energy should be less than 788 because we got a bigger distance between. Remember, we're still looking at Coulomb's law. So if we got a larger R, we got a less force, so it's going to be less lattice energy. So C and D are out. So we're left with A and B. Now we want to find out which is the good justification. Well, we said the BR radius was larger, so that means it has to be B. On number 7, we've got an alloy of nickel and boron. Nickel and boron. Boron is in period 2. Nickel is in period 4. So nickel should be considerably larger than boron. So that, to me, rules out everything but A. Right? If the nickel has to be way bigger than the boron. everything else shows them the same size, A is the right answer. Sometimes it's that easy. All right, 2 more on this set. Cleavage and brittleness. On this next one, we're looking for, it has to be ions. So A and B both look like ions to me. I'm not sure what's going on in C. It may just be a metal. It's definitely not a crystal lattice on C. So it's not C. And D looks like centipedes, which means they're probably big, long molecules, non-ions. All right, so now we got it down to A and B. And we want to know what happens when you hit it with the hammer. Why does it break? And if you notice that in A, after it's hit, after the displacement, the minuses and line up with other minuses and pluses line up with other pluses. And when you got pluses that together and minuses together, they're going to repel each other, and that's going to split apart. And you get a nice cleavage line through there. So it looks like A to me. B, you've got other problems because it doesn't alternate correctly. You've got whole rows of negative and whole rows of positive, and it should be plus, minus in every direction. And number 9, the white gold. We've got palladium and gold. Their radius is very similar, only a difference of 5 picometers. So that means they are about the same size, so they should be drawn the same size. And on A and B, they are drawn the same size. On C and D, they are not. So we can rule out C and D again because they're not drawn to the right scale. Now, that other part is, it says 75% gold and then 25% PD. So that's like a 3-to-1 ratio. Do you see that? 3-to-1? 75 to 25, 3-to-1. So we just got to find the one where there's 3 times as many golds as there are palladiums. And the golds are the ones that are not shaded, and the palladiums are the ones that look pink on my paper. So I'm seeing 3 palladium for every 1 gold on A, so that kind of rules it out. I'm seeing 3 gold to every 1 palladium on B, so that looks good. I like B. Again, I don't know what they were doing on C and D. It doesn't matter, because they're wrong. Okay, so that is the end of topics 2.1 to 2.4. Maybe we'll stop here, and we'll pick it up on the next video.